Now I'd like to take a moment and talk about water. All life is made up of mostly water. Humans, 65% of our body is made up of water. Jellyfish, about 95%. Okay, so it doesn't matter what type of organism you are, water is essential. Water exists in three forms. It's liquid from 0 to 100 degrees Celsius. Below freezing, okay, at this point when water is solid, it's essentially the same as not having water at all because it's not accessible. Above 100 degrees Celsius, water is boiling away and evaporating into a gaseous phase. So again, we're essentially saying there's no water present because it's not accessible to that life form. But why is water so critical? Liquid water is required for chemical reactions. You cannot have metabolism, the breakdown of molecules, unless those chemicals are dissolved in something. Water bonds. Okay, we've seen this diagram before. Water has one atom of oxygen and two atoms of hydrogen held together by covalent bonds. This shape is the result of polarity. One end of the molecule is slightly more positive, the hydrogen side, while the other end is slightly more negative because it contains more electrons. There's the uneven sharing of electrons. The oxygen atom has a stronger attraction for electrons. Water's partial charges allow it to attract to other water molecules and creates hydrogen bonds, these very temporary associations between one water molecule and the other. Water is one of the most polar molecules known on the planet. The ability to create multiple hydrogen bonds gives water many special properties, two of which, cohesion and adhesion, I'd like to point out. Cohesion is the attraction between molecules of the same substance. So what we're looking at here is water plus water interactions. When there is cohesion, when you have a cohesive unit, water is binding to water very, very closely. If there's no cohesion, there'd be equal spacing between them, no association. Cohesion is what allows insects to run on water, to appear to float on water. What's happening is the water molecules are bonding together and creating such a tense surface tension that the insect doesn't penetrate and break through. Adhesion is the attraction between water molecules and something else. A good way to remember this is you're adding something new, adhesion. Okay, so in this case, it's water and a leaf, or water and a stick. So here in this diagram, you've got cohesion on the right-hand side with water associating with more water, dipping down below the surface, and adhesion on the left, where water is climbing up onto the stick, defying gravity. Another interesting property of water is surface tension. It's a measure of how difficult it is to break the surface of a liquid. This is related to cohesion, how well those water molecules are binding to other water molecules. So you could try this at home. You could count how many drops of water does it take for dropping them on a penny to break that bubble and have it spill out. Right? Or dropping a paperclip in a glass of water. You can fill a glass of water to the brim and you'll notice it bubbles over for a while until then that bubble bursts and it spills. Okay? This is the same way that stain-resistant pants work. There's a chemical coating that increases the surface tension so that when you spill juice or coffee on your pants or shirt, they bead and just roll right off. It doesn't break the surface tension. Interesting things about water.